I have an altitude pressure switch here, and it's got a little plug here in the end. And there's a test that we do on these, and we have to unscrew this plug right here. And I mean, it's easy enough to unscrew the screwdriver. The problem is it's mounted up on the ceiling of a tight compartment. So it's everything you can do to reach up there and get to it. And these are angled the other way. They're not. There's two of these switches, one right in front of the other, and it can be a job to try to get these unscrewed. So normally what we do is we just dismount it, which is another little bit of a job because of accessibility. So I'm going to make a tool. Basically, it's going to be a tool to unscrew these. It's going to have a little pilot that goes in this hole. Here's a plug. This is what they look like when they're removed. And you can see there's a hole in it. That hole is 1/8 of an inch. That slot for the screwdriver tip is 50 thousandths. And there's a screen in the other end of these, so we can't have a pilot that goes too deep and damages that screen. But I do need the tool to be able to, sometimes these things are recessed like this one is. Sometimes they actually stick out a little bit. It just depends on how they screw in, how deep they screw in before they start tightening up. So I'm going to show what the tool looks like. I've already modeled it up here in Fusion, and this is what it's going to look like. And so basically what we got is just a little spanner that's going to be knurled so you can grip it. This diameter right here is about 400 thousandths, which will be able to fit down into if the plug is threaded too deep and it needs to go down in there to breach it, it'll be able to fit down into the threaded portion there. And then of course the pilot, the only thing the pilot's for is since this is kind of a tight accessibility area, you have to kind of reach up and around this switch, kind of like this. So you're down below, you're reaching up about as high as you can, and that pilot is just to help you find the center, so that whenever the tool's in there, you can either screw it in or out a lot easier. That way it's not going to slide off one way or the other as you're coming out or going in with it. Should be a pretty simple little project. I'm going to make it out of some 4140 that I have. The diameter of the knurled part is going to be 1 inch. This is, like I say, 400 thousandths. And then, of course, we got 50 thousandths ridge here for the slot, and it's 50 thousandths height. And hopefully you can see what I'm talking about. This right here. This part's going to be 50 thousandths. 50 thousandths wide, 50 thousandths high. This is going to be 1/8 of an inch pilot. And I'll probably bevel this. I probably should have done that already, but I didn't think about it. But this is just to kind of give an idea of what this tool is going to look like. Of course, this pilot will just be pressed in. I'm going to drill a hole, press a little pilot in there. Nothing's really real critical on this, as long as the measurements are close enough, and obviously the tool itself will fit the plug the way it should, then that's all we're really after. So we're not going to go crazy on trying to hit super tight tolerances. We're just going to kind of do this by eye and get the outcome that we're hoping for. Probably the most challenging of this project, as probably with most machinists, is everything on here is going to be a simple job. The knurling and getting the knurling perfect can be a challenge. But we're going to give it our best shot, see how it comes out. So with that said, let's go on out there. Okay, so the first thing we're going to do is we're going to just face it off and then get our 400 thousandths diameter that we need. We'll spin it up at about 800 RPM. Another 60 thousandths. We're going to go ahead and take another 5 thousandths. That was 401. I don't know if you guys can. .403, good enough. Okay, we're going to go ahead and drill the center hole. Okay, we're going to get set up for the knurls. Now this is where, you know, I mean, I want perfect knurls. Whenever I get perfect knurls, it just, I don't know, it makes you feel so good that you knurls turned out the way they're supposed to. I mean, it's actually not critical. There's an example of some perfect knurls. Probably could have used this piece right here. Probably should have used it, in fact. It's just a piece of scrap I had laying up there, but we're going to see how we do here. And the way I'm going to do this Forgot to move the camera over whenever I was doing this. Hopefully you can see that. Knurls came out nice and crisp. So I think that's going to work. So now, what we want to do move this back in, because we're going to end up parting it off. So far so good. Machine the slot in there, press a pin in it. Okay, so got the tool all set up in the vise. Got an aluminum B block, so I'm not going to damage the knurls on that side. Then I've got a piece of cardstock in up against this jaw here, the movable jaw. And I've just got a 1/2 inch roughing end mill in there. It was already in there, so that's what I'm going to use. And so basically what I'm going to do, I'm just going to come on down. I'm going to rest the end mill right on top of the part there. I'm going to lock the quill. I'm going to zero the knee. Then I'm going to lower it about 5 thousandths. I'm going to come off of it. Then I'm going to come up with the knee 50 thousandths. And then I'm just going to use I'm not going to bother, like I said, I'm trying to get this done as quick as possible. I'm not going to bother with a edge finder. I'm just going to come in and just barely kiss. I'm down 50 thousandths, so I'm already wanting to, I already know that what I'm going to kiss off of the part is going to be machined off anyway. So, and this is sacrificial. I made this years ago for another project, so I do plan on machining into this, no problem. So now we got to take 403 thousandths. We'll subtract 50 thousandths. That's going to leave us with 353 thousandths. Then I want to divide that by 2, and that's going to be 176.5 thousandths that we need to come off of both sides to give us our 50 thousandths along the center. So we're just going to call it 156. Then we'll measure, make sure we're pretty close to where we need to be, and we'll give that a shot. So 176 thousandths off both sides. Whenever I come in and kiss the side here, I'm going to zero the DRO, and we're just going to go off the DRO to make sure that we're good to go. So I'm just going to come in, I'm going to just barely kiss it. Okay, I think we're there. Come in 176 thousandths. Okay, that looks like it's going to work. We're a little under 50 thousandths. We're about 47. But I think that's going to be perfect. Okay, so got her done. Finished. All I did here with the pen was just press it in with the little press. And I had to machine this pen to get the right diameter that I needed. But so basically, the way it works is just like that. And the reason I wanted a guide pen or a pilot is so that it's held in there, you know, so that whenever you're letting go of it, when you're reaching up there, it doesn't try to fall out every time. And what I mean by that is, so like here's the pressure switch. I'm going to reach up there. The pilot is going to find the hole. I'll turn it until it's locked in, and then be able to spin it out of there. And then whenever it's time to go back in, the nice thing about it, whenever it's time to go back in, let me go ahead and take this all the way out. So I'll be able to put the plug on the tool, put it up, you know, in there, and then be able to spin it in. So anyway, that's it. The knurls look nice. I don't know how much that's coming through, but the knurls turned out great. All in all, probably going to last the rest of my career. And it's going to be a big time saver. You guys take care.